Hello, my name is Frank Shekhalif. I'm from Moscow and I will tell you some words about our team and about task you gave me on Upwork.com. I have experience in insurance and machine learning and analytics, have interests in autonomous intellectual systems. So, plan of demo: task understanding, define type of problems, find possible methods and solutions, start to analyze, understand specific points of task, then we will look at define additional metrics, then optimize with steps, removing goods and moving suppliers, for example, and start to analyze final decision. Okay, have a look at the task. So we have objective and we need to find cheapest total cost. We can increase the volume but have a target volume. We can drop some items and it is this and this. We have prices for each item. Best price, worst price, it's fine from here. Here is prices. We have minimum order of suppliers. It's 15 suppliers. So we have possibilities to exchange items between each other, and we have separation here for them. Also, algorithm should put how much order we should buy, putting in blue cells. So we should meet this criteria. This minimum order should be okay with this volume, and number of quantities should be okay with this column. So new constraints should be true for each cell, and total cost should be minimum. So this is the task. This first step, task understanding, then we should define type of problems for you. Okay, we will have possibilities to change target order, and we can change suppliers and we can change items. So it seems we have some discrepancy in the problem, so I think we should put discreteness. Yes, discrete task. For linearity we should put non-linear, because it's discrete and most of the discrete tasks are non-linear. Convexity, I think, it's non-convex, because we have we can have possible solutions, several solutions for tasks, because we can change suppliers, we can change items. This also add non-convex to space, and we have constraints. So for this type of problem we should then find possible methods and solutions, and I prefer to use open source here, because we shouldn't buy any program for now. Okay, we have done this and then find possible methods and solutions. For previous task I've used OpenSolver, so let's try to use it now. Okay, here's the site. We can find OpenSolver add-on for Excel, but we can do this task on Python, for example, or any other software, but for now Excel is much easy to use. Let's try to do it next set. So this is OpenSolver. We can download the latest version and try to understand, do OpenSolver have algorithm for our task. It should be nonlinear, non-convex, discrete, with constraints. Sorry for Russian language here, but we can now install Solver software. So let's have a look what type of models we have. Solver engine, look, and linear solver, linear. We have some non-linear solvers here, and we can try all of them, but I think the best one will be nonlinear non-convex solver for this task. Let's try it first. Okay, then we need to set objective cell, variable cells. Objective cell is data cost, variable cells is choice of suppliers with order quantity, and constraints we should use here. We should use constraints on 0 possible values, and we have constraints to target order, buffer to increase, and then we should think about dropping some items to find the minimum, and we should think about exclude some suppliers, put them to 0 order. In order to save you time, I'll show you a decision where I've done these constraints, variable cells and objective cell. Okay, we found possible methods and solutions for this task for now. Let's start to analyze. First of all, we have some specific points here. So we have supplier with one item possibility, and we have a supplier, we have item which we can buy from only one supplier, and price of it can be very high because only one supplier can support this item. So if we have a look, it's no outstanding points anymore, but of course we have situation here, but overall it's in general it's quite uniform. We have second supplier from 2nd to 7, which can give us a lot of items, and here suppliers with small number of items. I think we should try to take this information out algorithm. Also, all suppliers provide different prices, and I think we should also take this into account during building our algorithm. So let's build a chart where we have prices and difference of prices to minimum, and number of quantities to each other. Build this chart, and so we understand which suppliers can provide more for us and which suppliers can provide cheapest price. And we tend to choose suppliers with cheapest price and more items they can provide for us. Okay, I've built formula here. If it's non-zero, let's calculate difference this price, particular price to minimum, to best price we have for this item. So we have for each supplier we have price, we have different each price to best price for this item. And we can calculate then median or average for this supplier, and see that this supplier is quite cheap relative to its items what supplier provide. These suppliers are average and these suppliers are quite expensive. So if they provide items, these items is quite expensive relative to best price. And second thing we can see is number of quantities they provide. You just count of prices for items they can provide. And we see on the left side the suppliers with a lot of items, here, but here we have suppliers with small items they can provide. So if they give us quite a big price and can provide small number of items, it seems we shouldn't take them into account, because we already understand that they cannot give us optimal solution, because of minimum we should, if we buy from supplier, we should buy the minimum volume. So if we start to deal with them, it should be quite big volume. So let's try to build an algorithm like that. We start optimization task. We can find, for example, optimal solution for all of suppliers. Then we can start to remove suppliers one by one or by group. I prefer to remove these suppliers at one time and then find optimal solution and look at the results to understand which step should be next. Okay, we done the first analysis, understand general algorithm how we can choose suppliers, and we now can start to optimize task here. Also we understand specific points of task. It's 2 points, small number of items, or item we can remove from basket. It's one item and one supplier. It's also, I think, very important for us. Then we can do our algorithm with additional metrics after first optimization task. Okay, let's have a look at the model we have built. So we choose engine, objective cell, variable cells, and constraints. Now constraints are built for these white and blue cells, 2, 0 for white one. We have constraints to target order. Basic one, we have constraints to volume, minimum order for suppliers. Let's minimize our cost. So 1 second, please. Okay, so let's start to solve this open source. it's quite fast, this algorithm we choose. So we have first results. Okay, total cost is about 7,600. We have met constraints here. Everything is true. Istina in Russian, if you see here. And we have, let's add model. And we have true here, true here for these constraints, but we have some of quantities for it here. It's 1.2503, but I think it's not very important. We can just put 125. And we have problem here where gene and we see that optimization algorithm put values in different steps in different suppliers, and overall is 9.23, but we need only 2. So let's think how to deal with that. I think in general, because we have a strategy to remove suppliers, and these suppliers quite expensive, as we saw, so we will remove it from here, and these points will be removed. We can find solutions from these suppliers. So next step, let's algorithmically remove suppliers. I prefer remove all expensive suppliers for now. Okay, have a look at this item from first supplier and scope its census later. And if we divide number of minimum order to price, we got 12.6, 20.7, and it's non-removable. Can item be dropped from basket? And target order from 8 to 10, but for this price we can find only the minimum price. We can buy only 12. So first supplier is definitely we should remove, because we can buy from another items from it, and if we add for cheapest price, it's possible that our solution won't find constraints with these limitations. So just remove first supplier, put it 0 number of willing to buy to 0. For suppliers which give us possibility to buy with margin price less than 1.2, we also put minimum numbers of 10,000, so it means we can buy from them from minimum order to maximum order. This is maximum value, and put 0 to expensive suppliers in this one, which you can provide only one item, and have a look at this at the decision. Okay, let's add the constraint we have talked for now. So this is maximum volume order. Should be, and then we will buy and this one, and constraint. Okay, let's save model. And solve it. No feasible solution. Okay, it's possible. Let's think how we can deal with that. Okay, I have found that problem was that we need to define exactly 0. We should have for volume we buy from supplier, and algorithm will work much better. For example, here we put 0 and we open model, add new constraint, put here volume we calculate and put 0 here and constraint and save model. And now algorithm will find, I hope it will find solution with such constraints. Yes, now it's working. So step by step, just remove supplies with expensive prices relative to minimum, just to, and we see that the total cost is decreasing on each step. So we on each step we find more optimal solution. Okay, we save suppliers with relative low prices to each other and remove suppliers with high prices. Now we have 7,523 and then solve. It's 6,550, but we really need to understand what the minimum price we should have, and we see that if we choose between this one, second one is cheaper, we should choose it. First one here cheaper, we should choose it, and the second one from here is lowest price, so we choose it from these five items. And if we take some product between best price and target order from client, where we can and remove this item for expensive for supplier, which is 6, and 6 supplier is not quite expensive, but this we can remove this item because we have let's have a look at prices for second supply. So it's, for example, 51.89 from 6 from, oh, I'm sorry, 7 supplier have this little plank, and Seventh supplier is quite expensive and we want to remove it. So if we remove supplier, let's remove item from basket also. But this item quite is cheap from third supplier, and we want to keep this third supplier. This item, Gene Notes, is from 6 supplier, and we want to keep for now 6 supplier. And this item, Gene Query, cheapest one from 8, and we want to keep 8 supplier for now. Okay, just remove this one, leave it blank, because we can, and because we take cheapest supplier after that. And we find that the possible minimum cost for this combination is 6,430. So let's try to get this minimum price. Now we have optimization 605,000 approximately, but we need to play further. Let's build additional metrics. For example, this is some this is minimum price we have for these items, and this is our price we have, and we see that for aperitivo scenario we are not best, and for several items also we are not best. Let's after that let's concentrate on these items to find the solution. Okay, let's have a look at we defined additional metrics, and then now we are doing optimization with steps, removing goods and removing suppliers, and try to find final decision. Okay, and if we look at possible solutions, then we can remove also 8 supplier, as I do for now, and other suppliers. I have played with different one, and algorithm also can play with removing different suppliers and find minimum. So if I solve it now, I have found that if we remove particular blank, keep that one, choose the cheapest from here, and from here we find 6,440 approximately, and minimum we can find is 6,430. Well, it's about 10 difference, and it's quite close to minimum possibilities. And if we look where we lose for some items. Yeah. And the big lose we have a Gene Tinkeray. It's only one item. So can we change it to another suppliers? It's 93.48, and it's second supplier. Second supplier is quite cheap, and price of wheat also quite cheap, but we can change it this difference because of 8 supplier, and 8 supplier price 87. It's relatively low relative to second supplier, but items for other goods is quite expensive. So it seems we should keep this second supplier with a high price, because other items, and we buy it from second supplier a lot, is much more interesting for us. Okay, so overall this is solution of this problem. I think and overall the solution for your task for optimization of prices of suppliers and buyers should be working like that. So we just remove suppliers with highest prices and remove suppliers with a low number of items, and try to find minimum. And we can, if we can remove items from basket to find our cheapest supplier, we can also do that. So I think it's possible to build algorithm, a structured algorithm, and to transfer this code to Python or another language, and you can use it in your product. Hope for cooperation, and we'll wait for your answer. Thank you.